So now we want to take a look at this rational function. X cubed plus 3x squared minus 1x minus 3, I think it should say. We're going to change that. Okay. Minus 1x minus 3 over x squared minus 4. Now, this will factor, so we want to see what it's going to factor. But we also notice that the higher power is in the numerator, which means we're going to have a slant asymptote. So we want to do that division as well, okay? So it really doesn't matter which we get out of the way first. We know it's going to have a slant asymptote determined by the long division. So let's do the long division. X squared plus 0x minus 4. Accounting for the missing exponent there of x. So we put in the 0 for the coefficient. X cubed plus 3x squared minus 1x minus 3. Okay, x squared in x cubed goes x times x squared at x cubed. X times 0x is 0x squared. X times negative 4 is minus 4x. Draw the line. Subtract. Nothing left here. We get pulled down to 3x squared. We got negative 1x minus a minus 4x, which is plus 4x, which makes this a plus 3x. Next term comes down minus 3x squared, and the 3x squared goes 3 times, and that's really all the furthermore we need to go. X squared plus 0x minus 12, and I'm really the remainder I'm not going to worry about. This is going to be 3x minus 12, so it's plus 12 and it's plus 9. But that's written as 3x plus 9 over x squared minus 4. So my slant asymptote is the line y equals x plus 3. So I've got my slant asymptote, which is the line y equals x plus 3. Okay, I'm going to have verticals at when that's factored as you can see. Well, I might as well go ahead and factor it. Let's factor the top and the bottom. I think that the top we can factor by grouping, and the top we can pull out x squared, and we get an x plus 3. And then in the second grouping, we're going to pull out a minus 1 and get an x plus 3. And that's over x squared minus 4, which of course is a factor. This up top factors in x squared minus 1, x squared minus 1, and x plus 3 over x plus 2 and x minus 2. Okay, so fully factored now. We take a look at it. We've got the function f of x, which is factored as x plus 1, x minus 1 times x plus 3 over x plus 2 times x minus 2. So we now have our vertical asymptotes at x equals 2, x equals negative 2. Okay, we're going to have our, get this out of the way. We're going to have our x-intercepts at what? Negative 1, 0, 1, 0, and negative 3 times 0. We're going to have our y-intercept at, from the beginning, we can see it's 3/4. So let's put this stuff together, start taking a look at it as from a picture. Okay, so get everything together over here, see what we can get going as a graph. Try to get some things together. Okay. All right, so we have our vertical asymptotes at negative 1 and negative 2 and positive 2. Put our vertical lines in there. Okay, check. There goes our vertical asymptotes. We've got our intercepts at -1, +1, and -3. We've got our y-intercept at 3/4 positive. And we've got the slant asymptote, the line y equals x plus 3. So there's 3/4 is 1, 2, 3. We've got a slope of 1 up, 1 over 1. We also got this, so if I go down 3, I go over 3, which puts me through the x-intercept over there. So here's the guidelines for my graph, okay? Maybe you'll just switch up the color here just to graph it, okay? So I've got going through there and there and there, negative, so it's pretty well defined that it's going to go through here. Now I have another x-intercept here, and no other x-intercepts over here, so I can't go down through here because then that'll cross the x-axis. So looking at up here, and then well, I'm going to go through, and then I'm heading for the asymptote. So I think we're going to have that kind of flavor, which I think this is going to ride underneath the line. It's going to be less than the asymptote line, okay? And we could just sample some numbers to put in there. You know, I mean, it shouldn't take much, and if you weren't sure, you could always draw up a sine table. But I think, you know, I mean, if it's going to go through that point, then what we have to do is we have to go through it, and we don't have any multiplicity going through it, so we're going to go through it and then kind of dip down and then come riding along the asymptote. So there's your graph of that rational function with a slant asymptote, which we found by doing the long division. Once we get the line, we can pretty much toss away that remainder, and that would save us actually from having to do all that, the rest of that division, because once we get that defined as the asymptote, we can get it going. And so there you have it. And try the ones that I put on the worksheet for you.